Hello everyone. Today we are going to be determining the domain of a given function f of x. Now to answer this problem, we're going to first need to figure out for what values of x our function would be undefined in. If we see here, we see that we have two expressions within square roots, which means that our function is always going to be defined so long as these expressions are non-negative. So those are going to be our first conditions. We need the function to be such that x squared minus 2x is non-negative, and we also need it to be such that x squared minus 1 is non-negative. And we see here that we have a quotient, which means that our denominator down here, cosine of x plus 6 pi, also needs to be different from 0. So that is going to be our third condition. So we have cosine of x plus 6 pi needs to be different from 0. So if we can find an interval for which all three of these conditions are met, that is going to be the domain of our function f of x. So we're going to start off with the first two here. So x squared minus 2x has the common term x, so we can simply factorize it as being x factor of x minus 2. And our second expression here, x squared minus 1, can simply be written as x squared minus 1 squared. And this is the identity of the difference of squares, which would then give us x minus 1 factor of x plus 1. And now for both of these expressions, we can actually create a sign table to determine for what values they are negative. So we're going to start with our expression over here, x factor of x minus 2. So we have x going from minus infinity all the way to plus infinity. Our first term here is x, so we're just going to plug it in. And x is obviously going to be negative all the way up until x reaches 0, where it is going to cancel out, and then it is going to be positive. Likewise, the next term is also very straightforward. We have x minus 2, which is going to be negative from minus infinity all the way up until x equals 2, which is our second root, where it is also going to cancel out before becoming positive. Which means that our initial expression up here, x squared minus 2x, is initially going to be positive before canceling out and dipping down into the negatives, and then once it obtains 2, it's going to cancel out once more and resurface to the positives. Now we can go ahead and just do the same thing with our second expression here, x squared minus 1. So again, we have x going from minus infinity all the way to plus infinity. Our first term here is x minus 1, so we'll just plug that into our table. The value which cancels out this expression is obviously 1. Before this, it is going to be negative, and following this, it is going to be positive. And we're just going to do the same thing for our next term, which is x plus 1. And this time, the root is going to be minus 1. And before this, again, it is going to be negative, and then it is going to be positive. Which means our little expression here, x squared minus 1, is going to be initially positive before canceling out for x is equal to minus 1. Then it is going to be negative, cancel out one last time for x equals 1, and then it is going to resurface to the positives. This means our denominator is going to be positive for what values? Well, for x belonging to minus infinity all the way up to our lowest root, which here is minus 1. And then we're going to have the union, and then it is going to be positive for our highest root, which here is 2, all the way up to plus infinity. So that is our domain for the numerator. Now we're going to have a look at our denominator cosine of x plus 6 pi. So right here I'm just going to paste in our graphical representation of the function cosine of x. So we know from our high school math class that the function cosine of x actually has a period of 2 pi. But what does this mean? Well, this means that for our input x, if we were to add or subtract however many amount of times 2 pi, it would not change the output in any way, shape, or form, cosine of x. What does this mean, though, looking at just the graph? Well, if we were to take any given point in this graph, let's take x is equal to 4 and have a look at the image. So here our x is equal to 4. If we have a look at the image here, we're going down here, and then we are going to go left and see what value we have here on the y-axis, and we see that it is approximately minus 0.5, which means the output of our function is approximately, give or take, negative 0.5. But what would happen if we were to add 2 pi to our input here? So here we're going to add 2 pi. Graphically, this would mean we are moving to the right by an exact value of 2 pi. So we are now at this new point here, which is at approximately x is equal to 10. And if we go down here to our graph and see what the image is, we've reached the point with our graph, and we notice that the value for the y-axis is again minus 0.5. And this is what it means that our function has a period of 2 pi. It means however many times we add or subtract 2 pi to our input, it is not going to change the output of our function. But what does this mean for our denominator here, cosine of x plus 6 pi? Well, it means we can rewrite the expression as being cosine of x plus 6 pi minus 3 pi times 2. So here we're removing 3 times 2 pi, because remember, it doesn't matter how many times we add or subtract 2 pi from our input, it is not going to change the output of the function, which means we can rewrite our entire function as just being cosine of x, as both of these terms here are going to just cancel out. So we're actually looking at the values for which the denominator cosine of x is different from 0. So again, if we were to have a look at our graph here, we would notice the first point from the right hand side for which the curve reaches the horizontal axis, and this actually has a very specific value of x equal to pi over 2. But as we know, the cosine function oscillates up and down between minus 1 and 1 from infinity to infinity, meaning we have an infinite amount of cases for which our function is going to be attaining 0. But if we notice, there's a very set pattern, and there's a very specific gap between each of these points that reach 0. And the gap here is actually pi for all of these. Meaning, if we start here from our x is equal to pi over 2, and we were to add pi, we would again end up with a value for which cosine of x is going to be equal to 0. Likewise, if we were to go to the left-hand side and subtract pi, we would again find a value for which our function cosine is equal to 0. So how would we write this? Well, our starting point here is x is equal to pi over 2, and we are trying to say that no matter how many times we add pi, it is not going to change the output of our function 0. So we can say it is x equal to pi over 2 plus n pi, n being an integer. And that's it. So long as x is different from pi over 2 plus n pi, our function is going to be defined. So all we have to do is add up this domain and this one found here, and we are going to find the solution to our problem. So for our function f of x, we are going to have x belonging to minus infinity and then minus 1 here, union minus 2 all the way to plus infinity, and the unallowed values, which we are going to represent with a backward slash and open the curly brackets, are for which x is equal to pi over 2 plus n pi, n being an integer. And we are going to close the curly brackets, and that is going to be it. That is the solution to our problem. I hope you enjoyed the video, and I hope this was interesting. Thank you.